I'm asking how would you rate yourself? Synchronous execute parallelly.
Yes, ma'am.
How? What is the difference between synchronous and asynchronous here?
Means only 256 of data will be stored and remaining data will not be stored.
No. చిన్నగా చెప్పు ఎందుకు ఉరుకుతున్నావు? Hi Ruchita.
Hi ma'am.
Good morning.
Good morning.
Can you please introduce about yourself?
Yes ma'am. Firstly, thank you for giving this opportunity to introduce myself. My name is Ruchita. I am enthusiastic and self-motivated electronic and communicational engineering graduate with strong passion in VLSI design and verification. Now I am training at Verilog. We have trained digital electronics and Verilog and SystemVerilog. During my academics, we have done projects like LFSR and MIPS processor. By writing the code in design and test, we are testing in by writing test benches. And testing in models in QuestaSim, and I am quick learner and quick learner with problem solving thinking, and I am looking forward for VLSI organization where I apply my skills and learn from the industry experts, and thank you.
Okay. What are the projects you have did till now?
LFSR and MIPS processor, ma'am.
Okay. Can you please tell me what is mean by MIPS processor?
Yes ma'am. MIPS processor is nothing but multiple instruction per second. It contains a pipeline. In pipeline there are 5 stages: fetch, decode, execute stage, and write back, and memory access.
Okay. So how did you design this in RTL?
Yes.
All pipeline stages.
By using pipeline, we can reduce the number of instructions. For suppose without pipeline, we are using 5 stages. By using pipeline, we can reduce the instruction stages, and it will be easy to write the code.
Okay, fine. So how would you rate yourself in digital electronics, Verilog and SystemVerilog?
Yes ma'am. We have learned digital electronics and Verilog and basics of system.
I am asking how would you rate yourself?
Yes ma'am. 4.5 by 5 ma'am.
Okay, in 3.
Yes ma'am.
Okay. In digital electronics, can you tell me what is the difference between synchronous and asynchronous circuits?
Yes ma'am. For synchronous there is the same clock, and for asynchronous it contains a different clock. Where synchronous contains extra flip-flops and the gate. For asynchronous there is no extra flip-flop. Where asynchronous it will execute serially, where asynchronous it will execute parallelly.
Asynchronous execute parallelly.
Yes ma'am.
How? Can you design any circuit, any counter or register using asynchronous?
Yes ma'am.
Asynchronous counter. Okay. Now can you explain here how the asynchronous circuit is working parallelly and synchronous working serially?
Okay, I told reverse it ma'am. Before I tell it reverse now.
Okay. So how it is working here? Asynchronous means?
Asynchronous means it contains different clock ma'am. Previous flip-flop input will be the previous stage output will be the input of next flip-flop ma'am.
Okay. Next question. Can you design a D flip-flop with a asynchronous reset and synchronous reset using Verilog HDL?
Yes ma'am. Code?
Yes.
ma'am, can you repeat the question? D flip-flop for?
D flip-flop using asynchronous reset and synchronous reset
Yes, ma'am.
in Verilog HDL.
Here it is, ma'am.
What is the difference between synchronous and asynchronous here?
For synchronous, we are using passage clock. For asynchronous, we are using passage and gauge reset, ma'am.
Okay. Synchronous means
Up to here.
synchronous means we should not write the reset in a sensitivity.
Where clock and reset will be interdependent, ma'am. In asynchronous reset.
Okay, fine. Can you tell me in digital electronics what is the difference between encoder and decoder?
Yes, ma'am. Where decoder it contains n number of input and 2 power n number of outputs. Where encoder it contains 2 power n number of inputs and n number of outputs, ma'am. Where in decoder, if we give physical data, for encoder it will take the physical data as it is by using ASCII.
Okay, the physical data is converted to the
ASCII value. Physical data what we are giving in encoder, it will receive the same in decoder by converting using ASCII values.
Okay, you need to tell clearly. Encoding is nothing but the physical data, whether it's a image or audio, video, or even characters or uppercase letters or lowercase letters according to the ASCII table. The data will be converted to the binary. That is the process we call encoding.
Okay.
Decoding is nothing but the same binary data will be converted to the physical data. That process is nothing but decoding, which can be used in every communication systems.
Okay.
And what is meant by encryption and decryption?
Yes, ma'am. Encryption is nothing but what we are giving, we are like decoding, ma'am.
No. Encryption and decryption.
Encryption nothing but encrypt the data from what we are like physical data, it will converted into original data, like that is nothing but encryption.
Okay. Where did you find encryption word in real time?
Encryption. Encoder.
I think in WhatsApp you will see,
yes,
you
ma'am,
will
encryption.
find
Yes, yes.
256-bit end-to-end encrypted.
Yes, ma'am.
Means what?
Means only 256 of data will be stored, and remaining data will not be stored.
No. Encryption is nothing but whatever the messages we are sending, it is logged.
Okay.
It have some security. If you see, do you heard WhatsApp? Did WhatsApp is hacked till now?
Yes, ma'am.
Anywhere?
I heard.
Okay. How the WhatsApp is hacked?
Due to encryption.
Okay. Due to encryption, what is meant by encryption? I didn't heard till now WhatsApp is hacked, because WhatsApp is a very safest application we are using nowadays. In WhatsApp, till now, even ethical hackers haven't break the keys. Keys is nothing but whatever the message we are sending at transmitter side and receiver side, the both the information have some key, which is a lock, which is a binary digital lock, digital system lock. That's what we call encryption. Encryption is nothing but for the particular image, the key is locked. That key is revealed by the end of the user only. That's what decryption.
Okay, ma'am.
End to end, the messages are encrypted.
Means who are sending and who are receiving the data. Sending the data is encryption and receiving the data
is nothing but sending the data is encrypted means particular data will be having the key. ఇప్పుడు నువ్వు ఒక హాయ్ మెసేజ్ సెండ్ చేస్తున్నావు, లేకపోతే ఒక ఇమేజ్ సెండ్ చేస్తున్నావు, ఆ ఇమేజ్కి ఒక లాక్ అనేది ఉండిపోద్ది. ఆ లాక్ అనేది ఈవెన్ ఎథికల్ హ్యాకర్స్ ఆల్సో డిడెంట్ బ్రేక్ ద కీ, అంటే హ్యాక్ చేయలేకపోయారు. ఇట్ ఈస్ 256 బిట్ ఎండ్ టు ఎండ్ ఎన్క్రిప్టెడ్. అంటే అవర్ క్లాసికల్ కంప్యూటర్స్ ఆర్ సూపర్ కంప్యూటర్స్ డజంట్ వర్క్ టు బ్రేక్ దట్ కీస్. Very high level. We already discussed the quantum systems, quantum computers, how it will be working. Maybe in future, if the quantum computers come, within just 3 minutes, the lock will be breaked. They can hack easily. Quantum computers can hack easily.
Okay.
They work with very high speed compared to classical and supercomputers. That's what encryption and decryption.
Okay.
Okay, it's not related to digital or VLSI. It's a general question. Difference between encoding, decoding, encryption and decryption.
Okay.
Okay. Next. Can you tell me what is the difference between counter and a register in digital?
Yes, ma'am. Where register is a collection of flip-flop, it stores 1 bit data. Where flip-flop we use only 1 bit storer, register is a collection of flip-flops. Means many flip-flop will be used and storage will be more. Where counter is, it is also a collection of flip-flop. It is used to count the clock pulses, ma'am.
What are the applications of a counter?
In real time, ma'am. Digital watch.
Okay. Still?
That's it, ma'am. I remember only, ma'am.
Okay. Not only in digital watch, digital alarm, digital watch, any counting, any project, there will be a requirement of counter.
Okay.
Suppose protocol is there. Protocol is nothing but transmitting the data from end to end, transmitter to receiver. There we use the counter to count the number of bits, number of address locations.
Okay.
Like that. Okay. Okay. Can you write a piece of code for up counter, 3-bit up counter in Verilog?
Yes, ma'am. Here it is, ma'am.
It's a 3-bit counter, right? How it do
I need
the
to write
count?
3-bit, ma'am. Fine. Here it is, ma'am.
Okay. Okay. Suppose you are writing the behavioral modeling in this code.
Yes, ma'am.
Okay. And also if else.
Yes, ma'am.
And can we write case also?
Yes, ma'am.
Okay. Suppose in if else I am not using the else statement, and in case I am not using the default statement. So what are your observations in the RTL design?
Latches will be formed, ma'am.
Okay. What is meant by a latch there?
Latch is nothing but it is a level sensitive, ma'am. It contains race around conditions, ma'am. If latch conditions means to avoid race around conditions, we use master slave flip flop by cascading two forms, ma'am.
Okay. Suppose here how it is how it is getting the latch here?
In here, if we not use else or if we not use in case statement, if we not use default statement, we get latches, ma'am.
Okay. How it is forming the latch here?
By mux form.
No. Because memory latch is a memory state. It's a like a temporary memory state. So whenever the case is not available here, still we are running from the test bench. There is a chance of storing the data. The previous data is going to store in some temporary element. That's what it is getting the latch.
Okay.
It's extra. Yes, it is the extra circuit just getting in the RTL netlist. So how can we avoid that latch?
By using master slave flip flop on propagation delay and by using a flip flop.
Okay, good. But I am asking
In
behavioral modeling,
okay.
how can we avoid the latch?
By using else statement, ma'am.
By using else,
Yes, ma'am.
and also in case
by using default statement.
we can avoid the latch.
Latch.
Okay, good. Next, can you tell me what are the difference between always and initial
Yes,
and
ma'am.
assign?
Yes, ma'am. Where assign is a procedural statement, a continuous statement, where initial and always is a procedural statement, where initially will execute only one time, where always will execute in repeated once. Where for assign, in LHS side it contains only Y, and RHS side it contains reg and Y. For procedural, initial and always both contains LHS side reg and RHS side reg and Y, ma'am. Where always is used to repeat in a loop, ma'am.
Okay. Always is synthesizable or
Always
not
is synthesizable. Always is not synthesizable. Always is synthesizable. Initially is not synthesizable. Where assign is also synthesizable, ma'am.
Okay. What is the difference between forever, repeat, and for loop?
Forever always is both are similar, ma'am. But forever is not synthesizable. Always is synthesizable. Forever and always will be repeated in a loop continuously. Where repeated is used to print limited number of times, like a repeated of 10. If we give 10 times only, it will repeat, ma'am.
Okay. What about for loop?
For loop is also not synthesizable, ma'am.
How can we make it synthesizable?
By using generate block, we can make it synthesizable, ma'am.
Okay. What is meant by generate block?
Generate block, it is used to print the multiple statements in the single line statement, ma'am.
Okay. And also you can generate multiple blocks
Yes,
using
ma'am.
generate
block.
Okay. Okay, good. What is the difference between $finish and $stop?
Yes, ma'am. By using $finish or $stop, we can terminate the loop of always block and forever block, ma'am.
Okay. What are the major changes you have observed between $finish and $stop? Which one is mostly preferable?
Mostly preferable is $finish, ma'am.
Why?
Because if we give some limited number, it will terminate the loop, ma'am.
Okay. What about $stop?
$stop also it will terminate, ma'am. But we use $finish in EDA playground, ma'am. Mostly we use.
Not only in EDA playground, any tool we can use the $finish or $stop. It just terminate the loop. Okay. What is the difference between $display, $monitor, $strobe and $write?
Yes, ma'am. $monitor is used to print the changeable values. $display is used to print the immediate values. $strobe is used to print the updated values. $write is used to print the in same line, ma'am, like horizontally.
Okay. Dollar strobe is used to print the updated values. Okay. What does it mean?
Means if any updated value will be in the initial runtime, it will execute.
Okay, I think dollar strobe last simulation time value, whatever the in the same block, whatever the last simulation statement is there, that statement will execute in a dollar strobe.
Okay, last means all up statements will be last updated value only will be it will stored.
Yes, yes. Okay, fine. Can you write a multiplexer program in single line?
Yes, ma'am.
Single line logic.
By you. By using this condition, we can write the in single line code.
Okay. Can you write for full adder?
Yes, ma'am. Here it is, ma'am.
Okay. Can you write for encoder?
Yes, ma'am. Yes, ma'am. Here it is.
How much size it is? What type of encoder it is?
Any type of single, the code will be executed now. 2:4. 4:2, sorry.
4 is to 2. 4 by 2 encoder.
Yes, ma'am.
If I want to design 8 by 3 encoder,
Same, it will be executed.
it will execute for any type of encoder.
encoder, yes,
8 by 3 or 16 by 4 or 32
Yes,
by
ma'am.
5.
By using single line, we can reduce the number of lines.
Okay, nice. Can you design same logic for decoder in single line?
Yes, ma'am. I will try. Here it is. Box.
Okay. By a 5, particular I value will get 1, remaining all are zeros.
Zeros.
Will it keep zeros for remaining all?
Yes.
We didn't mention here anything.
Yes, ma'am. We need to make. It will allocate. I think we need to write it now. Zeros.
Y of I. Okay, y of I, suppose y of 2. 2 means what? 0, 1, 0. 0, 1, 0. Okay, only that 2 it will allocate 1 and remaining
We
all
allocate 0.
0.
Yes.
Will that work?
Yes, ma'am.
Did you simulate it?
Yes, ma'am.
Okay, fine. Okay, can you design serial in, serial out shift register in single line logic?
Actually, I don't know.
Serial in, serial out.
Actually, I need to try it from single line, but I don't try it.
Okay. Parallel in, parallel out?
In single line? Actually, I'm not getting anything in them.
For parallel in, parallel out.
Yes.
Okay, fine, no problem. Can you write a FIFO memory logic, memory write operation and read
Yes, ma'am.
operation?
Yes. Yes, ma'am.
Okay, fine. Next question. Can you tell me what is the difference between initial and not initial, task and function?
Yes, ma'am. Where function is a static. You are asking in Verilog or SystemVerilog, ma'am?
Both.
Where function is a static in Verilog and the function is a dynamic in SystemVerilog, ma'am. Where function is a block of code, ma'am. And it also performs some task.
Okay. Task.
Where task is used to perform some operation, ma'am. It is also in dynamic in nature. The delays will be added to the task. It will be used in the test bench.
Okay.
That's okay.
Can we use function in the test bench?
Yes, ma'am.
Task.
Task also.
Task also we can use. Okay. Can you draw the test bench architecture for SystemVerilog?
Yes, ma'am. Here it is, ma'am.
Okay. Can you explain the each block?
It's not. Where generated block, a transaction class is nothing but the input must be contains with rand and randc, where the transaction data is sent to the generator, and generator block is some data is sent to the mailbox, and mailbox is stored the data and sent to a driver box. where driver block is used to send the data to interface DUT, where the interface block is static in nature normally. By using virtual, it will be converted into the dynamic in nature, where the interface block is, where the driver is used to convert from packet level data to pin level data. Monitor is exactly opposite of driver. It is used to convert the pin level data to packet level data. And the scoreboard is used to check the actual output with the current output, ma'am.
What exactly we do in the transaction class in driver? Not driver, generator.
Yes, ma'am. Transaction class is used to send the data to the generator block, ma'am.
Okay. What we do in the generator?
Generator block, by using transaction class, we can write the code by using put get.
What is put get?
Put is used to store the data and sends the data, where get is used to receive the data, and
to where we are putting the data, from where we are getting the data.
In transaction class, now.
Wrong.
From mailbox into mailbox.
What is mean by mailbox?
Mailbox is used to work like a communicator between generator block and driver block, and scoreboard and monitor and scoreboard, ma'am. It is used to.
చిన్నగా చెప్పు, ఎందుకు ఉరుకుతున్నావు? చిన్నగా చెప్పు, ఆలోచించు. జనరేటర్లో ఏం చేస్తున్నాం మనం? ర్యాండమైజేషన్ చేస్తున్నాం. అసలు ర్యాండమైజేషన్ ఎలా చేస్తున్నాం? హౌ we are getting the data from the transaction class using the object? Why we are doing the randomization from transaction class variables? And why do we declare the inputs as a rand? Because we are using the randomization method. Randomization యూజ్ చేయాలి అంటే దట్ ఇన్పుట్స్ మస్ట్ బి డిక్లేర్డ్ విత్ rand కీవర్డ్. అప్పుడే ఆ ఇన్పుట్స్ అనేవి ర్యాండమైజ్ అవుతాయి. అవుట్పుట్స్ నెవర్ డూ ర్యాండమైజ్.
ఓకే.
ఆ ర్యాండమైజ్ చేసిన డేటా వీఆర్ సెండింగ్ టు ద డ్రైవర్ వయా మెయిల్ బాక్స్. మెయిల్ బాక్స్ ఎందుకు యూజ్ చేస్తున్నాం ఇక్కడ?
లైక్ టెంపరరీ స్టోరేజ్ పర్పస్.
టెంపరరీ స్టోరేజ్ పర్పస్ కోసం, అండ్ ఆల్సో సింక్రనైజేషన్ పర్పస్ బిట్వీన్ ద జనరేటర్ అండ్ డేటా డ్రైవర్ వితౌట్ ఎనీ డేటా లాస్ కోసం మెయిల్ బాక్స్ యూజ్ చేసి ఒక్కొక్క ప్యాకెట్ అనేది జనరేటర్ నుంచి మెయిల్ బాక్స్కి సెండ్ చేస్తా. మెయిల్ బాక్స్ నుంచి డ్రైవర్ గెట్ చేసుకుంటూ ఇట్ ఈస్ సెండింగ్ టు ద డియూటీ. ఓకే, దట్ ఈస్ ద ఫ్లో యూ నీడ్ టు మెయింటైన్ ఎవ్రీ స్టెప్. ఓ ఫాస్ట్గా ఉరికేస్తున్నావు. నువ్వు ఎంత క్లారిటీగా ఎవ్రీ బ్లాక్ ఎక్స్ప్లెయిన్ చేస్తున్నావు అనేది ఇంపార్టెంట్. కొన్ని మెయిన్ పాయింట్స్ ఉంటాయి ఎవ్రీ బ్లాక్లో, కొన్ని మెయిన్ పాయింట్స్ ఉంటాయి. లైక్ ట్రాన్సాక్షన్ క్లాస్ అంటే వీ డిక్లేర్ ద వేరియబుల్స్ అండ్ కన్స్ట్రైంట్స్ ఏమైనా ఉంటాయి అకార్డింగ్ టు ద స్పెసిఫిక్ ఇన్పుట్స్. మనకి స్పెసిఫికేషన్ బట్టి ఇన్పుట్స్ పర్టికులర్ వాల్యూస్ ర్యాండమైజ్ చేయాలంటే వీ నీడ్ టు రైట్ ద కన్స్ట్రైంట్స్. నువ్వు ట్రాన్సాక్షన్ క్లాస్లో అది చెప్పాలి. ఇన్పుట్స్ డిక్లరేషన్ చేస్తాము, కన్స్ట్రైంట్స్ రాస్తాము. ఆ డిక్లేర్ చేసిన ఇన్పుట్స్ జనరేటర్ క్లాస్లో మనము కాల్ చేసుకుంటాము త్రూ ద ఆబ్జెక్ట్. కాల్ చేసుకొని ర్యాండమైజ్ చేస్తాము. ఆ ర్యాండమైజ్ మెథడ్ వర్క్ అవ్వాలంటే ఇన్పుట్స్ అనేవి ట్రాన్సాక్షన్ క్లాస్లో ర్యాండ్ వేరియబుల్తో డిక్లేర్ అవ్వాలి ఆర్ ర్యాండ్ సితో డిక్లేర్ చేయాలి. ఆ ర్యాండమైజ్ చేసిన ఇన్పుట్స్ని వీఆర్ సెండింగ్ టు ద డ్రైవర్ త్రూ ద మెయిల్ బాక్స్ without any data loss. Every block have a specific functionality. You need to tell clear points of every block. Okay. ఇప్పుడు చెప్పండి మళ్ళీ స్టార్టింగ్ నుంచి.
Where transaction class, it contains the inputs will be declared with rand and rand c, where the inputs will be in generator block. It is the randomized to get randomization in generator block. The randomized data will be get from the transaction class, and it sends to the driver via mailbox. Without any data loss, we use mailbox. Mailbox is a communicator between transaction and driver block.
ఇంకా క్లారిటీగా లేదు. ట్రాన్సాక్షన్ క్లాస్ అంటే ఇన్ ట్రాన్సాక్షన్ క్లాస్ వీ డిక్లేర్ ఇన్పుట్ అండ్ అవుట్పుట్ వేరియబుల్స్, అండ్ ఆల్సో ఇఫ్ ఎనీ కన్స్ట్రైంట్స్ ఆర్ దేర్ ఫర్ ద ఇన్పుట్స్ వీ రైట్ ద కన్స్ట్రైంట్స్ ఇన్ ద ట్రాన్సాక్షన్ క్లాస్. interface is nothing but to connect the test bench and the DUT. But here system Verilog interface is same as a Verilog interface, which is a static in nature. But we are using every component is a dynamic in nature, because the class is a generator, generator is a class, driver is a class, monitor is a class, scoreboard is a class. So these all are dynamic in nature. So for that purpose we are recreating the interface as a virtual interface. అది ఇంటర్ఫేస్ కి చెప్పాల్సింది నువ్వు. అండ్ ఆల్సో ఫర్ సింక్రనైజేషన్ బిట్వీన్ డ్రైవర్ టు డియూటీ టు మానిటర్ వీఆర్ యూజింగ్ ద క్లాకింగ్ బ్లాక్స్ అండ్ మోడ్ పోర్ట్. ఆ కాన్సెప్ట్ ఇంకా అవ్వలేదు కాబట్టి పక్కన ఉంచండి. యూ నీడ్ టు ఎక్స్ప్లెయిన్ జనరేటర్, డ్రైవర్, మానిటర్, స్కోర్ బోర్డ్ ఎందుకు యూజ్ చేస్తున్నాం, వాట్ వీ రైట్ ఇన్ ద స్కోర్ బోర్డ్ లాజిక్, వీ కంపేర్ ద actual output with the expected output. All these combinedly we put in the environment. In environment class we call all these 4 subclass. The environment class is called from the test. Mali top level test bench lo we interface both test and the interface in the top level test bench. Okay. What are the different types of data types are there in system Verilog?
User defined data type, signed data type and unsigned data type, ma'am. Where in signed data type there are 4 types of different data types, like int, short int, long int, integer and byte. Where int and integer both are similar, but int contains 2 state variable and integer contains 4 state variable. Where 2 state variables are 0 and 1, where 4 state variables are 0, 1, x and z.
Int, integer?
Where integer both are 32-bit data type, ma'am.
What is the difference between both?
Where int is 2 state variable and integer is 4 state variable. Where int it contains 0 and 1, integer it is a 4 state variable, 0, 1, x and z.
What is the logic data type in system Verilog?
We use logic data type. We use logic data type to avoid confusions between reg and wire. Where logic
Verilog.
Okay, it's in Verilog.
Okay, fine. What are the different types of arrays we find in system Verilog?
Static array, dynamic array and associative array, ma'am. Where static array is nothing but collection of same array is a collection of same data types. Static data type is a fixed data type. Once the array of the memory size declared, we cannot change it. Where dynamic array is changeable. Once the array of the size declared, we can change according to the requirement. Where associative array is nothing but a spare array. According to the requirement, we can write the memory size, ma'am.
After the functionality is done, according to the functionality, whatever the size it is occupied, based on that it will allocate the memory. Okay?
Okay.
Fine. And in system Verilog, we have completed till object oriented programming.
Yes,
what is mean by class and object? What is the difference?
Okay, ma'am. Class is nothing but a blueprint, ma'am. Blueprint, it is a static in nature. Class is nothing but a user defined data type. Object is an instance of class. For that class we are creating object and the values will be stored in the object, ma'am.
Okay. What is the difference between inheritance and polymorphism?
Yes, ma'am. Inheritance means it extends from the parent class to child class, where the child class data will be acquired from the parent class. Where the polymorphism, parent class does not acquire from the child class. So to avoid that, we can write to override parent class methods or functions. We use from child class. Okay, ma'am. Polymorphism is nothing. Polymorphism is nothing but to acquire from the child class. You can override by using 3 methods. We can override from the child class into parent class by using virtual method and by using same function name and by assigning p equal to c, like parent class equal to child class. We can override the data, ma'am.
Okay, system Verilog, we have another mock interview. It have a huge concepts. In Verilog HDL, what are the different types of sequential executed statements and parallel executing statements?
Begin end is nothing but a sequential executor statement, and fork join is nothing but a parallel execution statements, ma'am.
Okay. What is the difference between blocking and non-blocking?
Yes, ma'am. Blocking, it represents with equal. Non-blocking, it represents with less than or equal to. Where in blocking, combinational logics are used. In non-blocking, sequential logics are used. In blocking, next statement
In
relates.
blocking combinational లో blocking యూజ్ చేస్తాం, sequential లో non-blocking యూజ్ చేస్తాం. ఎందుకు?
Why? Because it retains from the previous value and it does not store the previous values data. In blocking, it does not retains to the next statement in a non-blocking, ma'am. Where in blocking regular delays will be there, in non-blocking intra delays will be there. Where fork join and
చెప్పండి.
Where in fork join it is executed sequentially. Fork join and non-blocking are similar, but in non-blocking
Fork join execute sequentially.
fork join execute parallelly, ma'am. Non-blocking it will execute sequentially but concurrently due to intra delays.
Okay. You told that blocking is used in combinational, non-blocking is used in sequential. Can you differentiate that with drawing block
Some
diagrams
example.
with some example?
Okay, ma'am. Actually, I forgot the example, but I can explain it now. But if we take 10, A equal to 10, if A equal to B for blocking, the data will be retained from the previous value, ma'am. For in non-blocking, the data will not retain from the previous value, it retains to the next statement, ma'am.
Okay. I'm asking you the block diagram in the sense we have n number of flip-flops cascade.
Yes, ma'am.
So how it will work in for blocking and how it will be working for non-blocking.
Okay. I will try, ma'am, but I don't know. Why is it flip-flop now?
What I'm asking means, you will explain. A is equal to 10, B is equal to 20, C equal to 30. Okay, suppose here A, B, C. Okay,
Yes, ma'am.
suppose A is assigning to B, B is assigning to C. So, B is getting A, C is getting B. And put D also. This is a D. Okay, D is getting C.
Yes, ma'am.
So here A is a 10 means here B is getting 10. That same 10 is getting to C. And here same 10 is getting to D. So whatever the value is there in A getting D. Same. One single block is generating here.
Yes, ma'am.
Right. But coming to here B, A, same circuit, same example I am writing here, but just changing with the blocking to non-blocking. So here A is equal to B. What value the B will get here?
B will get 20 value, ma'am.
10.
Oh, yes,
A.
it's 10, yes.
What value will get for C?
20?
20. What value will get for D? 30. So here shifting is happening.
Yes, ma'am.
That's why For sequential logic circuits, we use non-blocking. Here, shifting is not happening. Whatever the initial value is there, assigning same value to D. So that's why we don't use blocking for sequential logic circuit. We use for combinational logic circuit.
Okay, ma'am.
Okay. You need to practice more on these two concepts.
Okay, ma'am.
And next, what is the difference between sequential access memory and random access memory?
Yes, ma'am. Sequential access memory, it contains FIFO and LIFO, ma'am. Whereas random memory, it contains RAM and ROM. Where FIFO and LIFO both are temporary storage device. Where RAM is a temporary storage device and ROM is a permanent device, ma'am. Permanent storage device.
Okay. In finite state machine, how can we design a Verilog programming?
For a person, ma'am. And
Just explain the steps. How can we define the present state, next state and remaining states?
Yes, ma'am. By using condition statement like a present state, next state, according to the statements, we can write the code, ma'am. For suppose if, can I write and say?
Yeah. You can take the sequence detector 1011.
For Mila or Mura?
Anything.
It is a Moore's sequence detector, ma'am. By using this present state, next state, if the value is 1, it will go to S1. If the input is 0, it will be in same state, ma'am. It's not. By using condition statement, we can write.
Okay. Just take that example. After this interview, just write the program, full program, and just show me the result. Do the simulation and show me the result. Okay. Okay, then yeah, it's good. I can give the rating around 7, but still you need to improve. You know the concept, but how the explanation should be given slowly. You need to talk slowly.
Okay.
Okay, don't run, because if you talk very fastly, you are skipping lot of words. Okay, so just talk slowly. Whatever the suppose example of test bench architecture, you know the concept, but you are skipping lot of words. Okay, just think, just take a second. You can ask the interviewer, can you just give 2 seconds time so that I can think and explain clearly. You can tell that and you can remember all the points, main hook points, and you can discuss. Okay.
Thank you, ma'am.
Yeah, thank you.